Hi, my name is Andrew from NLP.fun, and I'm going to teach you everything you need to know about the loops. The syntax for the loop is trivial, yet it's one of the most confusing concepts in computer science. So you can either spend 6 to 8 minutes learning the syntax, being confused, being frustrating, hurting your grades and your developer experience, questioning your decision to become a developer at some point in time, or you can invest the time necessary into the foundation and then carry through with an unexplainable sense of well-being, clarity, and understanding. Let me reassure you that the approach to explaining this topic this way is completely unique. Some might even call it revolutionary. In fact, I'm so confident in the approach that I'm willing to bet $10. That's right, $10 are on the line that this approach is going to completely blow you off your feet. Congratulations, you made through the first 50 seconds of the video. Statistically, there's a 90% chance you're going to watch it till the end. So to learn loops, we're going to take a basic task. Find a maximum number from a set of 10, and we're going to write a computer program to do it. Now, to put things in perspective, we're going to time travel back into 70s. A CPU back then had a magnificent speed of 400 kilohertz, and RAM was about 640 bytes. The computer system together in today's money went for, on average, $500,000. Now, let's go to the computer and actually do some work. I've put together a set of 10 numbers in Excel. Go ahead and find the maximum value. The number is 94. What more important is how you went about finding it. If you're like most humans, then your eyes went through the numbers, going up and down, scanning them in some sort of a fashion, until you finally reached the correct answer. Some people even go to the extent of verifying if their answer was indeed correct. A useful thinking pattern for those who are in school or at work. Now, if I walk you through a computer program that accomplishes the same task, you are going to get a bit confused because computer is going to do things differently. To maintain a sense of understanding and clarity, first we're going to take a look at this task from the point of view of a CPU. So I'm going to go ahead and update my screen. Waha! If you see a black screen, then you see what the CPU sees. If you hear nothing, then this is what CPU hears. Silence. Now, this is because the CPU and RAM are two distinct components. They look different, sound different, and feel different. This is what is called the von Neumann architecture. And for now, we're going to take a look only at the CPU and the memory. Other players are going to enter the picture at a later time. What happens is data is being uploaded to the memory together with CPU instructions on what to do with it. CPU then fetches or gets data from RAM. It also fetches instructions what to do with data. CPU stores data and instructions into CPU's internal memory. You might know it by the name of cache. It is much smaller compared to RAM, but it's much, much faster. It's a very common trade-off in programming, the one between speed and size. Now, for the reasons that are going to become apparent later on, the standard operating procedure is for a CPU to fetch data one number at a time. Depending on the generation or the architecture being used, this explanation can be labeled as technical fairy tale. but it works just fine for educational purposes. Now, the CPU fetches data from the memory one number at a time. So let me go back to the CPU perspective. Now I'm going to adapt CPU fetching data to human experience. Watch. That's how CPU perceives data being stored in memory. This adaptation is heavy on visual senses. I'm going to expand this experience using additional sense. How would a similar operation sound? Well, I had recorded 10 numbers in 10 separate audio files, and I'm going to listen to them one number at a time. 36, 24, 48. So this is how a CPU would experience data stored in RAM using auditory sense. What about feelings? A metaphor that uses them goes like this. I have a kid's toy in my hands. Some numbers are imprinted. I'm going to close my eyes and feel what the numbers are. One number at a time. Feelings usually take a little bit longer in terms of time compared to other senses. So the next time you are at an appropriate texture, maybe the numbers are engraved or are raised up like the letters on a building or whatnot, take some time, close your eyes, and feel the numbers with your hand. The richer your experience is, the better you are in the long run. Now that we had built our intuition, I'm going to go back to primarily visual modality, simply because it's faster. I'm going to restart and go from the beginning one more time. Okay, how many numbers did we go through so far? Can you tell? Or can you see? Well, we need to keep track of how many numbers we had examined. Because if we try to access memory that doesn't belong to our program, well, then the program is going to be shut down, as it tried to perform an illegal operation. For example, somebody's password is being stored right after our 10 numbers. It would be a security issue if our program could gain access to that chunk of memory. So we need to keep track of how many numbers we had examined. I'm going to do it right here. Okay. Let me go through a few numbers. Now, I'm going to start from the beginning. The second thing that I'm going to need to keep track of is my current maximum value. Since my CPU memory is even smaller than my RAM, I need to be very careful with how much memory is being used. Now, we're going to use one slot for the current value, the second slot for the counter, and the third slot is going to be used for keeping track of the current maximum. How did I come up with this? I didn't. A bunch of other smart people did. They got together way back then and figured out the most effective and efficient way to perform this type of operation. Okay, now I'm going to go through my 10 numbers. All right, we got 36, number 1, I guess, and it is our current maximum. 24 is our number 2. It's less than 36, so we don't need to update this value. 48, bigger than 36, so we're going to update. 41, less than 48, don't need to update. 54, bigger. 70, bigger. 38, smaller. 94, bigger. 74, smaller. 72, smaller. But we're done with our 10 numbers. Great! We had encoded the solution to this puzzle using human experience on the basis of computer architecture. Now, let's take a look how the solution is encoded in Java. I'm in a software called Eclipse. By the way, throughout my long career, I learned the best when I was not doing any code along. I learned the best when you understand what you're doing first. Now I'm going to go ahead and run the program. Yep, it works. Now, what's different? Did you notice what is different? Take a look around and notice what is different. Over here, we have the number 94 displayed, okay, which happens to be our high score value, the maximum number. So we now had established two things. First, the program works. Second is where the output or the result is displayed. Great. Now I'm going to go through the program step by step, execution-wise, in a similar way as a computer would do it. Our objective here is to observe the execution pattern. See this line that is highlighted? The computer is about to execute this instruction. Now this one. Now this one. Okay, I'm going to continue with the rest of the program. And we're done. Now you had noticed that the computer went from the top to the bottom, executing one line of code at a time. This particular code block had been executed 10 times. And then the computer went down and finished the program. The code block is referred to as the for loop. Let me clean things up. The word loop here refers to the program looping back to the beginning of the code block as many times as specified. Okay, let's go through the code itself. The first line here is the magic code. When you're learning coding, and sometimes later down the road, it's very common for you to use the code that you don't fully understand. I like to refer to it as the magic code, as it just magically does the things that we need it to do. And we're going to discover the details later. So this one is going to be labeled just magic code. The next line has something to do with a thing called array. You can think of it as a table that we had used in Excel. Or better yet, you can think of it as a dresser. Each shelf of a dresser holds a particular value. I'm going to go into details about arrays and more specifically about the term zero-based. And a super easy way of understanding it in a different video. For now, I'm just going to draw this for you. See, the humans count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A computer counts differently. A computer counts 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If this doesn't make sense right away, it will, after watching a video dedicated to array. For now, just file this picture away to the back of your mind. All right, the next line of code represents us drawing our little table where we were writing down our current candidate for the maximum value of the high score. Finally, we get to the for loop. Even though, for all intents and purposes, the for loop here takes only 2 lines of code, there are lots and lots of things happening. This is because the syntax was designed way back then when people were trying to jam as much stuff into a single line of code as possible. I was walking into a bar the other day and I saw a guy, a bouncer, holding a device in his hand called a counter. For each person who would walk into a bar, the bouncer would click on the counter and the numbers would increase. And I thought, this is a good metaphor for a for loop. Actually, in computer architecture, there's a small device that is called counter. Surprisingly, the syntax for it is exactly the same as for the for loop. The syntax of a for loop breaks contemporary styling conventions of 1 line of code, 1 action, and actually packs 3 actions into 1 line. To make things easier to understand, I'm going to rearrange the for loop for the educational purposes. In practice, also known as real life, nobody writes loop these ways. But for educational purposes, it works really well. All right, I had rearranged the loop, and I also added some comments or notes about the things that we had already talked. These lines are not going to be executed. The green lines are for human reference only. I had also labeled this line of code as the magic code. I want to focus our attention on the syntax and the mechanics of the for loop, and I want to keep the rest of the code as light as possible. That's why I had reorganized my code to move the details of this line someplace else. It actually takes a few more lines, but for now, we really don't care about it. For now, let's focus on the for loop itself. The first line is only going to be executed once, at the beginning of the loop. The second line acts as a condition, a check, a traffic control device that will direct the execution of the loop to within the code block of the for loop itself or the next line after. The final line specifies how much the counter or the index variable is to be incremented by. Okay, now let me traverse the loop from this point of view. In our case, the first line of code represents the action of us creating a placeholder for the counter. We had confirmed that this was done only once. You also saw that at the very end, computer had always executed this line. We can interpret this line as execute first instruction within the loop block until we had counted to 10. After you had counted to 10, continue with the rest of the program. This line of code simply adds 1 to our counter. Even though there's lots and lots of information to go through, 90% of the time you start from the first element, usually 0, and go to the last element, whatever it is. And you increment things by 1. Formally, these guys are known as initialization, condition, and update counter or index. All right, let me put things back to the conventional quote-unquote way and run them at the speed of thought. Here we go. And we're done. Okay, so why the for loop was invented there in the first place? Well, let me write an alternative solution for the same task. On the left, we have the for loop version of the solution. On the right, we have the brute force version of the solution. Instead of looping through the same line of code and incrementing counter by 1, I had manually copy-pasted 10 lines of code, our magic code that will update max value if needed, and I had manually incremented the counter by 1. Okay? Now, this is not a huge deal when it comes down to a small subset of values as we have right here, but imagine we are to expand our high score table to tens of thousands of entries. Do you want to be sitting down there writing tens of thousands of lines of code of essentially the same thing? I know that I don't. Next, this solution, for all intents and purposes, takes 4 lines of code. This solution takes 10 lines of code. This solution is going to be independent of data amount. This solution is going to grow with data. The more data we have, the more lines of code we have to put in. The more space we're going to take at RAM, the slower the program is going to load. Take another look here. This line had been essentially repeated using a human. But over here, this line is being repeated by a computer. So this is the very first time you see a pattern called reuse your code, commonly known as do not repeat yourself. In fact, the pattern of reuse your code is baked into the for loop. The for loop on the primitive level is the first demonstration of a foundational computer development paradigm. Reuse your code. So a for loop essentially had been developed a long time ago. It is unusual in its syntax because it consolidates 3 lines of code. And it's a very, very clever way to save RAM and speed the execution of the program overall. Okay, now that we had talked in great amount of details of the code used to implement the for loop, I'm going to jump into ways of thinking. But before we transition, I had consolidated a whole bunch of code into this line. Want to know how it looks? Well, it's right here. It involves a dedicated function that will update the value of the max value, return it, based on the current value of the high score. It uses the function ability and the if statement. I talk about these things in a different video. Check the description for details. Alright, so let's jump into ways of thinking and build up your intuition. My smartest way of thinking about the for loop is the following. Let's say that we have a chunk of code with the for loop right here. Now, there's going to be many iterations coming through. You can imagine the first iteration as a snapshot from a photo camera or a frame from a movie film. Now, as the loop goes on, potentially there could be different things happening. And you can stack those images, diagrams, movies, scenarios, one after another, just like you would stack printed photographs or movie frames. When you look at the entire code, let's say you're looking at a small chunk of code and you see a for loop, then you can imagine a layer of loop iterations resting behind the for loop block. Let's take a look at the syntax for the for loop in different C-based languages. Languages that were built using syntax of good old C. This is how we write a for loop in Java, as we had explored in excruciating amount of details. The exact same syntax is for C and C++. And JavaScript syntax is almost identical. Some scripting languages like Python and Visual Basic attempt to simplify the syntax of the for loop and make it more intuitive. There's one major difference in how they treat the condition, the exit condition of the for loop, and I had dedicated a different, quick video for that topic. For now, let's move on with the C-based languages. When you write your code, or when you read the code of other people, the letters and the characters on the screen are going to appear very, very small. You can easily fit few for loops on the screen of a cell phone. This is okay for practical purposes, but not very useful for training. So we want to add an additional way of thinking big. Imagine a huge piece of paper in front of you, and imagine attaching 3 wooden plates to it. If you can, make them different color. Now, take the image displayed in front of you on the screen and increase its size to the size of the appropriate element that you had just imagined. Do the same thing with this image. If you need a practical example to solidify your understanding, then imagine what the for loop is primarily used for. It is used to examine values in a table. The first element of the loop corresponds to the first position of the value in the table. In the zero-based world, this position is 0. The second element in the loop corresponds to the amount of items in the table. The third and final element is a counter. 95 times out of 100, the counter is incremented by 1. What I want you to do right now is to imagine your mental file that we had just created for the for loop structure and close it. This is your base. It's nice, clear, and well organized. You can rely on it in the future. In the event of slight confusion and whatnot, you can always go back to your base. For now, I strongly recommend taking a break. It could be as long as 2 days or as short as a small walk. The idea here is to solidify your base. Inevitably, you're going to go to the outside world to gather more information. Just like with everything in computer science, there's going to be lots and lots and lots of stuff out there. So, objective number 1, look for the 10% that applies. Because in practical terms, 90% that's out there does not apply. It's simply useless stuff. Now, when you do find something of value, create an additional folder for it and label it variation or an add-on or additional information. Some people make a whole copy from their base. Others just include the information how to get from the base to that particular variation. For example, I have my solid base for a for loop in a C-based language, and then I need to learn how this structure is implemented in Visual Basic. So I'm going to create another folder, title it for loop Visual Basic, and I'm going to derive all the things that are slightly different from my base and mentally put them into that particular folder. This may sound like a little bit of a theoretical stuff. Trust me, it will pop up at the appropriate time in the future at the appropriate scenario. It's going to run there at the back of your mind, doing its magic thing. All right, guys, this marks the end of this video. So thank you for watching. If this video helped you, click like. If you want to know more, come back soon. Now, if you have any questions, feel free to ask them in the comments, and I will do my best to answer. If there are any topics that you want me to develop, ping them in the comment below, and I will do my best to explain. Thanks for watching one more time, and I'll see you in the next video.